and satisfying to then be introducing this amazing tool set to our students here at Gnomen, the next generation of visual artists in this industry. Gnomen students. Gnomen students. Yeah. All right. Thank you. So these Autodesk events are about connection, pulling back the curtain so you can meet the real people and behind the tools and hear directly from the artists and developers shaping this industry. Autodesk is here not just to share what's new in their world, but to listen, answer your questions, and support our creative community, especially as industry continues to evolve. Whether you're a student, a working artist, or somewhere in between, we hope tonight gives you some insights, inspiration, and practical takeaways. And speaking of takeaways, we do have some great Autodesk takeaway swag, so don't leave when you're done. We will have a drawing for Autodesk swag. Yay, swag. And if you want to keep the conversation going after the event, please connect with people in the Autodesk team. They do want to hear from you and move things forward. So I'll give a quick introduction to our presenters here this evening. We have Mark Sturley, who's a technical specialist with Flow Studio. We have Dwayne Rutowski, who's a Maya technical specialist. We have Jean-Francois Charbonneau, who's a former VP of Tech for Guru Animation. And we have Jose Elizardo, who's a technical specialist with 3ds Max. And we also have Sean Willis, who's senior technical artist and pipeline TD from Crafty Apes, will be talking to us after we have word from Autodesk. So hit it away, Autodesk, thank you.
Awesome, thank you, Bo. As Bo said, my name is Mark. I work as a technical specialist here at Autodesk, and I'm here to demo Flow Studio. And so you may be asking yourself, what is Autodesk Flow Studio? Flow Studio is a cloud-based 3D toolset that transforms a single source video into pipeline-ready CG scenes. So you don't need the traditional mocap stages, suits, special cameras, all that complex setup. You can get mocap and export elements straight from a single source video. And as you can see in this live action example, you've got the mocap, it's generating a clean plate, it's got your character paths that's all getting composited together into your live action footage. And all this is designed to be super friendly for your traditional pipeline, so you've got export elements like Maya, Unreal, 3ds Max, via the USD scene export, and then of course anywhere else that you can use USD. So yeah, let's dive into how some creators are using Flow Studio today.
Cordo Digital is a really cool studio. It's about 12, 15 people at any given time. We've been around for over 10 years at this point. And we primarily focus on making action, comedy, VFX-based short films, and it's a lot of fun.
We're constantly looking for ways to save time because, we don't have the same deadlines as feature films, right? We're putting out videos every week.
The thing about doing virtual characters is it's a huge pain in the butt. Years ago, I made an entire 20-minute short film featuring a virtual character. It was called Scooty. Camera tracking, motion tracking, all of the lighting. It took months and months of constant work on the VFX. Last year I worked on a short film called There's an Alien in My House, and it was a challenge because on top of all of those VFX, we had to do it in the span of about 2 weeks, which is just a ridiculous deadline for anything involving virtual characters. When I heard about Wonder Studio, I was like, this is amazing. You can fully film a short film the way you would normally and film your actors on camera and be able to direct them naturally, and then just pipe it into this software and it spits out a virtual character, and you don't have to do all of that manual work of the tracking and the mocap and the clean plates and everything. It just allows a much more free-flowing creative process of working with actors.
The ability of Wonder Studio to play nice with all of the other tools that we have in our pipeline is, to me, the most exciting thing about it and the most useful thing about it.
It lets you export the camera data and the lighting and the motion capture. And so for certain situations on my project where I needed a little bit more artistic control, I could go into that third-party program and use Wonder Studio's output to help assist me as an artist.
Over the last few years, we've played with a lot of different AI tools. Wonder Studio allows an artist to still be an artist. It allows you to focus on being creative, and the software just takes care of the boring parts.
A lot of the time, as an independent artist, You want to make really ambitious projects that just aren't feasible. But, sometimes you have to do it as one person. You don't have a bunch of money or a bunch of people backing you, and you still have this creative vision that you want to express. And so Wonder Studio is going to be an invaluable tool for these kinds of people where they can go after more of those ambitious ideas and shoot for the stars.
Awesome. So as you saw there, at the core of Flow Studio is the markerless motion capture system, which is capturing movement of your actor and converting that into animation data. And this is available as a standalone motion capture project type, and that comes out as an FBX or USD format. But you can also use it in a full live action project, as you saw in that video. And you can retarget that to a fully rigged CG character that you build in Maya, Blender, or wherever you're building your characters. You're going to get a camera track, a first pass at the camera track, which is super important when you're working in a 3D scene. So you'll have that character, the camera track, and a point cloud that you'll be able to open up in your 3D scene. And as mentioned, we have DCC outputs, Maya, Blender, the Unreal scene, and then the USD scene, which could go into 3ds Max or NVIDIA's Omniverse and other tools like that. And then you'll get a character pass, which comes out as a PNG. You can put this into your compositing software, bring in your clean plate, and sort of work with it from there. And you'll also get an alpha mask, which can also be used in compositing workflows as well as color grading or wherever you're using the alpha mask. And then the clean plate, as mentioned, that's just going to remove your actor from the plate. And you'll get an export video, which we really like to think as like a first pass or maybe a post-viz pass that you can go ahead and throw into your VFX edit. Then you can take the export elements, bring them into Maya, bring them into your compositing software, tweak them, finish them up, and then put those back into your final VFX edit. And another thing we offer is facial performance. So we work off the FACS system, and we support up to 88 unique blend shapes. So you're going to get any facial data from your actor converted into blend shapes on your character if you have blend shapes set up. And one really cool project type that we just released is called the animation video to 3D scene. And this is similar to our live action project type where it's grabbing that mocap animation, but it's also prioritizing 3D space to get you into a full 3D scene. And if you have, for example, an establishing shot, a close-up, a medium over the shoulder, it's going to track what's behind you and keep that character consistent in 3D space, allow you to kind of manipulate the cameras, manipulate the animation within your 3D software, and get you, much better starting point to your final shot. We also see this as a great tool for previs, stunt viz, layout stuff, for example. This was a stunt team that we've worked with on a proof of concept with Kyle Potter and Makia Chow, and they're a really talented stunt team. And we see this as a really cool use case to, just previs out your stunt shots and make sure that that's kind of what everyone's envisioning before you get out on set. And then one other really cool feature we have is the motion prediction. So as you can imagine with the single source video capture, when you don't see the actor, it's going behind an object, it's hard to get the animation because the camera doesn't see it, right? So what motion prediction is doing is taking the motion from before or the motion after, and it's filling in the gaps of what the camera doesn't see. And so this is a really great tool, just gets you even closer to that 3D scene. And yeah, let's just want to take another look at how we've seen Autodesk Flow Studio being used in a production environment. We worked really closely with Voxel, who I would say is definitely a power user of Flow Studio. And they used Flow Studio on Superman and Lois as almost like a substitute for motion capture. So they did some we worked with them really closely doing these initial tests of, doing similar kind of like a stunt viz type of thing to make sure that it could fit into their pipeline. And then on set, they were actually, instead of going into a motion capture stage and setting up the suits and all the markers and all that, they were just grabbing a single source video and then transferring that over to their into their 3D scene without using like all the data wrangling and mocap stages and all the traditional stuff you need for a mocap setup. And then another really cool thing is you can use it for reference animation. So they didn't get these shots on set. Their animators were in their offices or at home, and they were just doing some pickup animation, and instead of using it to reference, they could actually run it through Flow Studio and get that animation right into Maya and composite into their shot. And they also used a proxy workflow, so you can do really complex rigs. If you have a really complex Maya rig, you can essentially grab that data from Flow Studio and then retarget that to your proxy character and do that real fine-tuning that you would be doing in traditional mocap workflows. And then
Voxel is a high-end visual effects studio. We are storytellers by heart and engineers by the craft.
We started working on Superman and Lois. We're gonna need to be more efficient. I wanted to bring Flow Studio in, giving the client more creative freedom. It's a reality right now that people who are gonna thrive is people who know how to use those traditional tools and embrace them with AI. Autodesk has been always standard in our industry. With tools like Maya and now with Flow Studio, they've been embracing some of the new technologies.
Autodesk is being a great partner to give us the confidence that we need to deliver the best quality content. I think AI is coming to really empower the artist, every single artist, to have like 10 times more power to deliver better content, better quality, and in a better speed.
Cool. And with that, I will pass it over to Dwayne, who's going to talk more about the Autodesk AI initiatives.
Thank you, Mark. Hey everyone, how are you? My name's Dwayne Rutkowski. I'm a solutions engineer here at Autodesk. Before we begin, I just want to say thank you to Marcel Dion and Alex Alvarez for starting this. I'm a previous Gnomen alum from 1999. Been in the industry about 20 years, and anywhere you go, it's always positive feedback on Gnomen, its students, so its reputation definitely precedes itself. So let's get started on Autodesk AI. A few things I'd like to cover are currently the state of the industry, the Autodesk Transparency, the Autodesk AI Lab, which was started in 2018, and some challenges that we're facing as artists. And before we begin, I'd like to start with a safe harbor statement. So a lot of stuff we'll be seeing is out in the open. Some of the stuff that may be forward-facing, deadlines shift, priorities shift, so please don't make any purchasing decisions based on them. So kind of driving anywhere in LA, driving through the valley, right? So, up in the Bay Area, San Diego, there's this strange sentiment of humans bad, replace humans, right? It's just such a strange, weird time that everyone is just calling for it, but one of the things I'd like to help bring to the forefront is the Autodesk philosophy on AI. So the Autodesk philosophy on AI is to put the artists first, right? We're here to empower the artists. We're here to empower the artists in the workflows. So the artists, you guys are the ones who drive. You guys are the artists, the ones who create. We use AI to give the artists time and ability to explore with more iterations. When we couple that with the insanely amazing GPUs that we're seeing right now and amazing tech, it helps with those growing production needs. Game productions, film productions, they're out of control. So at Autodesk, what we're really trying to do is make sure we're rising to those challenges and making sure that those needs from the artists and studios are met. Now, we at Autodesk, we support the artists' processes and we want to accelerate their workflows. So we want to allow them to stay focused on quality as well as practicing your craft. One of the things we want to put at the forefront, though, is visibility. And with that, we're using these transparency cards. So there's 4 different principles of trust that Autodesk likes to incorporate with our AI. So we want to be responsible. We want to be transparent and upfront. We want to be reliable. So the data sets, the models we're working with, we want to apply them to you once they're going to work, predictable, no surprises. And of course, we want everything to be safe and secure. Many of us, we've been at the other side using Autodesk products in production. We know that there's safety issues, we know that there's security issues, we know that there's a lot of IP. So we listen and we're adhering to the feedback. So with these cards, a few different things you can notice. So if there's any type of functionality that includes AI, any type of functionality that includes machine learning, we're going to mention it. We're going to talk about where's that data set coming from. Is that data set on our side? Is it going to be on your side locally? So we want to have full transparency with this. If for any reason, before starting a project, or if there's something else, any questions, always feel free to reach out to us. We're happy to connect, and we want to make sure everything works out for you, the artist, as well as the studio. Now, a little background, as I had previously mentioned, we have Autodesk AI Lab. Now, this was founded in 2018, and since then, there have been 90+ peer-reviewed papers. So when we think Autodesk, we know we have, Maya, Max, which we love, but then there's other pillars within the Autodesk company. So we have AEC, Architectural Engineering Construction, D&M, Design and Manufacturing. Now what happens are there are parallels between a lot of these papers. So there's a lot of research that goes into different graphics for, let's say, another solution, AutoCAD. Research development that goes into different solutions for Revit. Okay, so a lot of this information also transfers over to rendering pipelines, modeling pipelines, and so forth. And these data sets, all these papers, they are available to read online. Now, another thing we have is we're not always doing this alone. We team up with universities such as MIT. We're able to go through and do these extensive studies, which lead to better results, better quality testing, and then in the long run, we'll end up delivering better products and better features to you, the artists. Now, kind of looking at some of the challenges we're at right now. Let's step back a few years, and we could say humans, we were doing about maybe 65% of the work, right? But then when we fast forward, current time, maybe about 5 more years, there is about a split, 50% of the work, and then there's this gap. And then trying to figure out this gap of, was it lost work? Was it lost to people being replaced? Or on the flip side, was it lost to artists leveraging different types of AI to help support their workflows? Artists leveraging AI to speed up their workflows to get a certain percentage forward. So with that, it's important to try and have AI at the center of your development strategy if you're not only just an artist, but also as a studio. So make sure your employees know the studio's AI vision, and make sure it's one that's focused on developing skills, talent, and rewarding innovation, not replacing works in technology, AI, or otherwise. And some further things we can look at are, in the industry, we have challenges of different types of specialization issues, right? So with game production, we'll have issues where everyone will be on the same project, but not all that data, not all those different tasks are being shared across. This could be for reasons such as you're using proprietary tools, there's proprietary data sets. So it may not scale from one project to the next, and it may not scale from one job to the next. Now there's also an issue of studio fragmentation. Studios, they've got secure properties and very strict guidelines with working with other studios and clients alike. So we can be in many situations where the left hand's not talking to the right hand, and that could lead to extreme amounts of frustration, that could lead to extreme amounts of knowledge just simply not being transferred. And then if we're looking at a very top level, a higher level, there's industries in M&E that they don't necessarily incentivize outcomes or operational outcomes. So then that can be another issue of all that work gets done on tools, processes, workflows is essentially lost or just simply can't be shared. So what we're noticing is our largest customers are beginning to recognize that their organizations, they don't hold enough data to train foundation models, and they need to collaborate with others to determine if they're willing to share and create mechanisms to do so. Now, Autodesk feels very strongly this effort should be led by the industries themselves. And with that, looking at a few ways we can kind of mitigate these challenges. Looking at ways that our organization's relationship to AI, some of the things, steps forward to take. As I had mentioned earlier, we have the Autodesk AI Lab. Customers can join the research community, and you could try and get on early betas. Now, with those early beta software, you can participate in different surveys, interviews, and more. Big reason a lot of studios, a lot of users are on the betas, they like to see where we kind of have our attention focused, what we're looking at. And then if it's in line with what the studio's project is, whether it be a film or game, they can align to that. Another thing they can end up doing is accelerate the move to the cloud. So with studios being everywhere, not everyone is localized in Los Angeles. Studios are more remote than ever across not only different time zones, different countries, but completely spread about. So being able to have those data sets that are reachable from those other studios is key. And then having that single source of truth, that will help with the AI model as well too. So if that's spread across different areas, or if it's fragmented, it could be hard to get an accurate and precise representation of what's needed from all that data that's collected. And with that, I would like to pass this forward. Thank you.
I'm number 3. Give it a second here. There we go. Thank you so much. Okay. We can see my screen. And thank you for the introduction. Thank you for having us. Like in the intro, my name is J.F. Charbonneau. I'm a senior technical specialist here at Autodesk. I come from production. I worked in production for 23 years. The first half was in video games. The second half was in animated series in Toronto. But first, I was an artist. I worked as an asset artist, creating content. Then I became a CG soup. And it's only after a few years that I moved over to the technology side, where I was director of production technology, working with TDs. I had a team of 10 excellent TDs putting together solutions to very complex problems. And then I moved over to the position of VP of technology for a studio of about 400 people. Had the pleasure of moving a studio virtually during COVID. And what I want to do tonight, though, is really present the material from my lens, which is first as an artist, but also as someone who's excited by technology. I want to create things, I want to make things, and that's always my first lens. And then secondarily to that, then I think, oh, okay, a studio, I want to have everybody working as productively as possible, delivering shots, and getting the work done. So I'm going to talk about Autodesk Flow first, which is kind of this overarching project to develop a platform that many of our applications will connect to. The idea, of course, of a platform is that you can share services, things like security, login, a lot of the kind of the foundational things can be taken care of from one team, infrastructure, but then you can build industry-specific cloud solutions. And of course, Autodesk has many verticals, and that's where you have different industry-specific clouds, but for M&E, it's called Flow. That is the one that is specific to our industry, our types of data sets, and so there are teams working on that right now. And that explains a little bit of some of the naming that you may have encountered out there in the wild. But the idea, of course, is to have the ability of developing new ways of working, new types of cloud-native applications where your data can move, but also to connect our core applications like Maya to the cloud to enhance and bring more value and to connect, because we certainly see that as the future of work. But there's already cloud-native applications in our portfolio, and we'll take a look at a couple first, and then we'll go into Maya and other elements. But you may have seen some rebranding recently, where when I started, I was working on Shotgun, and then that got rebranded to ShotGrid, and now it's called Flow Production Tracking. I'm going to talk a little bit about that, and really the naming indicates that these applications are getting connected to the broader platform, opening up new ways of working. And I'll talk a little bit too about Flow Capture, formerly known as Moxion. So one of the things you can do when you are in the cloud and you're connected is that you can come up with new ways of leveraging this technology. Last year at SIGGRAPH, we released Flow Generative Scheduling, which is an application, a cloud-based application, where you can bring in your data from Flow Production Tracking and generate scenarios. Because if you've been in production, you know that it's not if things are going to go wrong, but when they're going to go wrong. And updating schedules is one of those super time-consuming things, especially when you're trying to run scenarios and kind of what-if scenarios. It's manual work, it's time-consuming, and it takes too long to update. And often, by the time you have an update, something else has happened. So what if it was possible to adapt the schedule more quickly? And that's where Flow Generative Scheduling comes in. And so if you've worked with schedules, you know that they're really just a bunch of constraints that are strung together to compose an entire sequence of production. You have all these building blocks. In Flow Generative Scheduling, you have all of those constraints brought over from Flow Production Tracking, and then you can display that and have your kind of starting point, but in a sandbox. And this is what we're seeing here. This is the data coming in with all of those constraints, and you can display the resources, which are your departments of people working across your various shots, across your production. But the magic is when you start to be able to take that data in a sandbox, make a copy of it, and then start to play with constraints. And you can play with constraints at the project level. You can say, this whole project needs to be moved down by 3 months, and then put that as the first constraint. And then the second one is, I need this sequence to be produced first. And then you can run the generate scheduling again, and it'll come back with a proposal of optimized resources. And of course, it's an idealized version of your schedule where you've strung together all your constraints as quickly as possible and by minimizing the fluctuation in your resources. So you don't have people coming on and leaving and coming back on. You try to flatten that curve, and this is the beauty of this tool. You can do these scenarios, try things, and then push your data back out. So that's one application that's possible when you're connected. More recently, like this week, Autodesk also made available in public beta, so it's out there now in Flow Production Tracking, our new creative review tool, which brings all the best features of a review tool together, but with added functionality. It's now possible, and you can try it, to do a live synchronized collaborative review, which means you have different people jumping in and being able to collaborate at the same time on the same media. Features like hold and ghost and comparing modes, and being able to go back to notes that are saved locally. So kind of a refreshed experience for your reviews. And speaking of Flow Studio, the motion capture data there is me walking in my kitchen, filmed on my iPhone, and then I was able to map it to a character. So very easy to leverage the technology. Here we're seeing some of the features to be able to A/B compare different versions, and you can swipe across. So very useful as you're going through different versions. You can jump from layout to final render. So if you have a chance, give it a try. We think you'll like it, but we're looking for feedback on this. And here we're seeing just connecting multiple people into a review session, but because I didn't have any friends this morning, there's only me in the session here collaborating with myself. Then there's Flow Capture, which you may know as Moxion. Same thing, rebranded, also connecting to our platform over time to unlock some of that value, and to signal that this is also getting connected into the platform. But if you don't know this tool, Flow Capture solves the problem of how to share footage on set with all the people everywhere in the world. And its main feature is that you can review the highest quality footage securely from anywhere. And it's used on sets today, in productions, and we'll just take a quick look here. So when you're on set, everything you do there is in service of generating the image, but there's the visual data, but then there's also all the metadata, the very important material to pass into downstream departments. And that's one of the things that you can do very easily with Flow Capture, is to actually push that metadata forward with your shot, and then it becomes available for filtering and selecting all of your footage. So you have the possibility of doing your on-set production, your post-production, your camera to cloud, and also your remote finishing and review in HDR. And here we're seeing the interface very quickly, so you can have all your footage up in the cloud and select what you're looking for, and then share that footage out to your teams with very high security. And so you can organize your production, and some of the features include things like digital right management, so the screen goes black if someone tries to do a screen grab. There's watermarks, there's forensic watermarking available if you need it, multi-factor authentication, and fine-grained access. There's also kind of an executive experience where you can look at the content on iOS devices. And the other killer feature is what we call the Flow Capture rooms, which gives you the possibility of doing a live remote collaboration on footage. You can have as many as 25 people in the room. They are on camera, so you can actually have a conversation all in one experience. So everyone can see the same thing. It even records, if you comment and say, hey, this is low resolution, it records the resolution that the people were looking at. If it was 720p, that is recorded. And that's, here we'll just see a quick look of what that looks like. You can have all your people in one room looking at your footage. So that was the flow production tracking and flow capture. Next, I want to talk a little bit about open source. It's one of those topics also that is very popular in the industry, and it's very important to Autodesk. So, of course, you're familiar with a lot of the projects. Autodesk champions, many of them contributes to many of these projects directly. There's OpenUSD, of course, which is central to many pipelines increasingly, but also MaterialX for describing materials, OpenColor.io for the transforms on your colors. So there's all these projects that are fundamental to the way increasingly that we work, and they are at the center of how Autodesk now develops many of our applications. These are some of the projects. We're also a founding member of the Alliance of OpenUSD. There is an open communication between the community and the various partners. Open standards and open projects are only as useful as people can actually implement things where the data actually moves from one application to another successfully. If everybody has their kind of siloed version of these projects and are going on a tangent, then it's very hard to create a cohesive ecosystem where you can successfully move your data around. So getting those conversations going and making sure that there's a consensus on how to implement these things is super important. And at the center of that is the Alliance of OpenUSD. If you're curious about these projects, there's also our GitHub, which is open, and you can come and visit the various projects. So wherever there's our commercial application and an open source projects, there'll be a open source project on the Autodesk GitHub that is the link between the two. And you can see the evolution of those projects. You can see the commits and actually look at the code of what's happening. So we invite you to take a look at that if you're curious. It also gives you visibility into the sort of things that we're concerned about and what we're putting resources into. So it's a great place to look at, and there you'll find Maya USD, for example. So that's for open source. Now I want to talk a little bit about our core applications. I also started with Maya in 1999. It was not version 1, but version 2. And it's very near and dear to my heart. I've worked with it pretty much my entire career. And now let's take a look at some of the new features that are showing up in Maya this year. We'll talk a little bit about modeling, animation and rigging, simulation in Bifrost, and I know there was a presentation from Sean after, and I can't wait to see that. And then we'll talk a little bit about rendering in Arnold. So last year, in Maya 2025, we introduced some new features like Smart Extrude. This gives you kind of a little bit of insight into the way that our developers are thinking about features. This is all about keeping the artist in the flow of creation. When you're modeling, you don't want to be thinking about vertices and edges, or as little as possible. You want to be just creating. And this Smart Extrude tool does some of that work for you, where you can extrude in and it removes the faces and just gives you clean geometry very easily, keeping you in that flow. And now in Maya 2026, with work done on booleans, and I don't know if you're working with booleans, which may have been challenging in the past. If you've tried the new Boolean experience, which is based on a stack, looks very much like a 3ds stack with all of its awesomeness and how you can move around your different elements and play with your components. With that stack, you can now enable volumetric conversion. So you can do volumetric modeling in Maya as you're building your geometry, and it's close to a sort of procedural workflow because everything is live. It's reactive, and you can move your components around and experiment and play with it and come up with a mesh, and then you can decide what you do from there. But it's very tactile, and it's a way of playing and putting the artist certainly at the center of the creation process, thinking less about technical elements and more about the outcome that you need. Then, thank you. Then here we're seeing some of the features for retopology. So there's now a way to do flow retopology. So if you have your computer and you don't want it to lock up, it's now possible to take a mesh, submit it to the cloud, do the retopology in parallel, and you can submit multiple meshes up in the cloud, and then the compute happens over there, and it sends you back the result, which means that your computer is still available, and you can do more fun things. And so this is kind of looking into these cloud connected enhanced workflows. Here we're seeing, so in rigging, last year also, we introduced machine learning deformers, ML deformers, which is really just a way of capturing super complex, or maybe simple, but deformation that is whatever you've created, and then capturing that deformation, recording it, and creating a very good approximation through machine learning. And of course, the longer the machine learning process runs, the better quality output you get. But what it does is, and this is critical in animation studios, is that it gives you a very good, very fast approximation of your deformation, which means that your artists, your animators, can work at speed without having to do some of the optimization that might otherwise have to be done. So essentially, you record the deformation, you turn off the super heavy one, and you temporarily turn on the fast proxy one, you work, and then you can decide to switch back and forth. And in Maya 2026, now there's more tools to visualize the delta between the geometry the deformation that you had originally and the one that's being produced by the ML deformer. So it's a very powerful tool for accelerating workflows. Also on the theme of connected workflows, in Maya 2026, we're introducing a new feature called Animate in Context, where you're connecting your Maya scene to flow production tracking, and it's showing you the shots around your sequence. So if you're working on shot 30, you can bring in shot 10 and shot 20 and shot 40 and 50 and see it in your timeline. And as you're scrubbing your animation, you're now working in context. And that's one of those connected workflows. So on the Maya side, it's released in 2026. On the flow production tracking side of things, that's still in beta, but the team is working on those components. And yeah. Then of course, as we're moving forward, we're hitting Bifrost and simulation. This is where I spend a lot of my time these days because it's an endless playground where you can do things. At its heart, it's a visual programming framework. So often pipeline TDs, technical artists will look at that, but also as they are creating tools or compounds that can then be pushed into different departments, and then they can become users of those compounds. One of its main advantage is that it's just in time compiled, so it executes fast. A lot of workflows and a lot of pipelining can be done in Python, for example. If you're sensitive to speed, there's some things you may want to consider building in Bifrost, for example, because it is fast. And I remember maybe 7-8 years ago when it was first part of Maya, I got a presentation at the studio, and it was very much centered on simulation, and it has evolved immensely since then. The simulation is still at its core. It does that very well, but now it's gone into different directions too, because when you have visual programming, you can go in many directions, and these are some of the user examples of some of the work that's done in Bifrost. We're seeing here some volumes and some particles, but also some NPMs simulations. So of course, if you can play with different things, people do, and this is one of my colleagues, Roland Reyes, who built a procedural geometry tool where he can, from a terrain start building up blocks and then subdividing those into different buildings. So it's possible to create tools and looking at things in production. This is one of the super powerful things where you can be a multiplier. You can do just a lot of work very quickly. Beyond geometry, also working on procedural rigging and a modular framework. This is just released in the last few weeks. So I've worked in a lot of studios where the question is always, how do we standardize our rigs? How do we offer the highest quality rigs possible to our animators so that it feels like a puppet and they know where to find the controls? So one of those, the foundational principle is often about modular things that you connect, and that's now possible in Bifrost. Beyond the Bifrost side, it's now also fully integrated with Maya. So there's Maya side menus to create the skeleton and to connect both sides. So you're essentially driving and creating the skeleton on one side, and then you have your Maya skeleton on the other side actually in your scene. And over the last few years, we have users that are very much playing with Bifrost and rigging and animation. The example on the left is a good one where that's interactive. So someone is moving a target, and then the little robot there is running after it. Other examples here of procedural rigging and some of the effects that are possible, interactions, just custom effects. Tools, you can build tools with it. So pretty much the USD API is available within Bifrost at the most basic level, and so you can start to build up these USD templating workflows to create things like different representations of your assets. So if you have a tree here and you want to create a volume-based geometry, you can do that. And where you see proceduralism, you can tackle things like terrains and world building. Recently, the team added texturing as read and write nodes, so you can read in textures and inform where you scatter, for example, your trees that you built with your USD tool. All of this all of these tools can play together, and you can start to really build clever solutions to problems. We also introduced wedging recently, towards the end of last year, where you can with your simulation submit different wedges, so you get back some results based on what you need, and you can submit that up to the cloud. Also in the release just this spring, there's now liquid in the graph. So Bifrost, sort of Naiad, if you think of those original simulations, now it's possible to have it in the graph and control it in the graph. I say control it in the graph because you have all the data, and you can start to do interesting things. If you want to find a point somewhere and pin something, you have control over the data. And here we'll see some more of these are tests, internal tests, but it kind of shows you what's possible within Bifrost liquids. There's a bunch of resources online. If you're curious, you can of course through YouTube, and we can have a chat after if you're looking for entry points. But we have a Discord channel where our production teams and some of our developers are very active with the community, and you can actually chat with some of the people who are making the solution. So very very close to the community. And I'll just conclude here this portion with Arnold, a workhorse renderer that's included as part of Maya, as part of 3D Studio Max, but is also has implementations available in Houdini, Cinema 4D, and Katana. Just high quality, very efficient. You can take in large amounts of data, and it can render it. It's possible to use it on the CPU and on the GPU. On the GPU side, the team has always tried to make them as close as possible to pixel parity, although there's always fundamental differences. And as part of M&E collections, you can get 5 batch licenses. But Arnold, over the last several years, the team has been focusing on performance, and there's been some quality improvements pushed out recently. So now there's faster procedural instancing, and you're seeing some of the speed ups there when you hit render. But also non-photorealistic rendering is really trendy right now, and a lot of studios are leveraging it to get your own look out of the renderer, and we have a lot of clients who do that, and we're seeing some examples here, which you may have seen. Speaking of the GPU, it's now possible. There's a first version of GPU tune rendering. So the parity between the CPU and the GPU side is getting closer and closer. So you can take a look at that. But also the team has made it possible to look at your render logs through a beautiful HTML report, so that you can more easily gain insight into your rendering. And now your render logs can also be attached to your snapshots, making it easier to work through your rendering. And of course, as we look at rendering, there's always shader and shader definition. MaterialX in Maya is our project for authoring open source shaders. And we've been working with Adobe to create a standard open PBR surface, which is now the default in Maya 2026. And the benefit there is that you can have your shaders moving around from application to application that implements that standard. Also on the GPU side, we can now render cryptomats. And I'm going to finish with this. One of the options that was recently released is the Global Light Sampling, GLS, which has this like super awesome non-linear speed up as you have more lights. So instead of rendering every light, there's actually some calculation that goes in ahead of time, and you get some speed ups. So it's one of those functionality that if you're spending a lot of time rendering, take a look at that, make sure you're enabling it, because the savings, even when in a scene where you have 9 lights here on the right, there's still some important speed ups. And that wraps up my very quick tour of some of the platform, the open standards, and also the core applications. Thank you.
Mic's not on. No. Hello? Hello? My mic's on. Oh. Your mic's not on. His mic needs to be on, not mine.
Hello. Thank you. Let's talk. Thank you, JF. Let's talk a little bit about MotionBuilder. So we know MotionBuilder is a solution where we're able to intake motion capture, intake BBH files. We can also stream motion data within the motion capture and take it to other solutions to work with, such as Maya. There has been a lot of work happening in the background with MotionBuilder. One of the big things is a jump in 2023, and with that, that's when Python 3 became exclusive. So in MotionBuilder 2022, you could still use Python 2, but there was also a flag where if you needed to use Python 3, you had the ability. 2024 had a symmetry edit for character control panel, as well as collapsible and an expandable action panel. But when we move to 2025, this is where a lot more functionality starts coming in, especially with USD. Being able to bring in a stage and also ability to lock global take and time mark. And moving a little forward with progress in 2026, we also see that the interface, the icons look a lot better. That's because it always runs in high DP mode now and works well with high DP displays. There's also USD animation properties that were brought in. So when you're loading a USD stage file, the animation contained in the file will now be rendered. So with this, it's also possible to slow down, accelerate, or even apply different time warping effects to the animation. And then a big one right here, selection updates. So you no longer have to jump in the browser, outliner, you could select within your viewport, which is extremely helpful. And with MotionBuilder, you're able to bring mocap into our solution, which is Golaem plugin. This is one for its huge crowd simulator. Now, you don't necessarily have to have these big, massive armies to be crowds. You can start from as little as 2, 3, and build them up. You could build up character libraries. You could have different types of path navigation, so characters marching in lines, characters marching across different types of terrain, different types of undulation, so it doesn't necessarily always have to be that flat surface. And within this environment, we see that this work is done across many different areas. We see a traffic system, we see work done in feature animation, we see work done in TV episodics, as well as different coliseums and crowds. So here's a few more projects that were used with Golaem. One of the things that you could do is pop onto the Autodesk website, and we actually have a feature right now with Arcane. Really well done, a lot of good visuals, a lot of good stuff to read up on. And then trying to figure out, who uses Golaem. It's not necessarily the bigger studios, the mid-sized studios, or the more boutique studios. The user base is all across the board. You don't even have to be a crowd artist by trade to jump in and be functional with Golaem. Now, there's a few ways that Golaem has helped stand up artists in their workflows. So there's different path planning and navigation to help with moving a character or an army of characters across a scene while also avoiding props and different elementals. Now, there's also visual diversity, while being easy to swap out clothing, armor, different outfits, as well as shaders. And the placement tools are extremely helpful for after the fact. So you spend all the time running your simulation. You bake it out, you're able to use the placement tools to edit, which is extremely valuable at the art direction level. Now, there's also a physics engine that relies under the hood for different types of collisions, cloth, and hair. And then the behavior editor. This is where a lot of people will spend their time in. This will be where you're crafting behaviors and then reactions with the crowds, having them move towards and from things. So the procedural animation tools as well. It's great for a non-destructive workflow to help with adding more diversity in that animation toolkit. And now something with Golaem as well too is being able to take your cache into USD if you need to take it into Unreal. And if you need to do any type of rendering such as in Max, you have the ability to do so. So I want to jump in and show a little bit on just how the ease of Golaem, how it is. Let's see here. Okay. Let's see. Seems my Maya window's not picking up here. Just need to get my Maya window up.
Windows P. Windows P. Do a duplicate. Select duplicate.
Oh, perfect. Nice. Thank you. Ooh. All right. Let's see here. I have my. I've got a scene right here. And with this scene, a few things I have set up. So I have my initial terrain laid out, and then we can also see I have different objects in my scene for collision. And then from there, I had imported a character. So let's go through and just play it. First, what we want to do is we actually want to go and we want to populate our scene. So with the population in Golaem, we have quite a few different things we can do, right? So we can see that we can, individually go through, place different characters if we need to. We have different shapes we can draw out, so we can have our characters spawn in within the shapes. We also have different types of volumes. So if you want to do a type of swarm, you could have bees coming out of a beehive within that volume. And then you also have the ability to paint if you want. So you can go through and you can paint on your terrain where the characters will be. And then you can also go through with the My Selection. And if you want to have them spawn from any types of components, you have the ability to do so. Whether it be out of vertices, you can draw different path curves and have those characters spawn from there too. Or if you'd like, you could spawn from individual polygons. So if you have a crowd or a coliseum scene, you could have individual seats with individual polygons, and then those characters will spawn from there. So for this, let's go through and we will go and create a square, and let's drag out just a simple area where we want our characters to pop up. Now we'll see about 5 chevrons, right? What's great about this is the interactivity of Golaem. So we're able to go through, and if we want to have more characters, we can just add more slots. So if we want to pop up, let's say do 100 characters, we have 100 in our scene. And from there, we're going to go through and we want to create that. So going through and playing it, what we see happen is, there's our characters, okay? Everyone pops up. This isn't geometry that's written right now. So what's great about this, it's not AI. You're the artist, you have control, you can do what you need to do. What we want to do is we want to have these characters move towards this treasure chest that I have up here. So the workflow in Golaem, it essentially goes from the tab from left to right. So the next spot we want to go to is we want to go in here in our behavior editor. This behavior editor is we're going to be editing the types of movements, the types of behaviors for our character. Now, as I mentioned before, I brought in this Roman soldier, and we see we have what's called the flow. So the flow is essentially where we're going to be putting our logic. And what's great about this is there's so many different types of nodes based on basic movement, basic needs, that you don't necessarily have to go and reinvent the wheel. So the first thing we want to do is we are going to drop in a BGoTo shape. Now from there, we see we have two different options. We can reach, whereas the characters will try to go to a certain area, or we have a flee. So this would be ideal if you're doing a scenario where you have different characters trying to run away from an environmental hazard, you have characters trying to run away from an incoming monster. So good stuff with that. Now, taking into account the different terrain and the different obstacles I have in the scene, we have the navigator. So if I close this, let's see what we got in terms of movement. All right, so we have our people moving forward. We see everyone's kind of shooting up the middle, but then they're a little bit off to the side. And the great thing about Golem is it's so interactive and it's so iterative. You have the process, like I said, with control, which is great. So kind of layering in different things we need to do, we will go back to our behavior editor, and we want to add locomotion to this. Now, locomotion, this is what's going to determine what happens when a character gets to an area they need to go around, right? So we'll open this up, and let's load in our movements. So if you notice some of these movements here, they're offset by different numbers. These are offsets to degrees. So this will factor in those different degrees when you're doing your character setup, how the characters need to move, how they need to pivot to make their way around those types of obstacles. And with those loaded, all right, we're going through and we're seeing motion. Okay? So let's say we want to take it a step further. They're kind of shooting past that chest, and we don't want that to happen. So let's add a node where we ideally would like them to head towards. And from there, we're going to go back to the go-to. And instead of doing a random target, we want to pick our pop tool, and then we want to define that pop tool. So now instead of having the stragglers off to the side, everyone's shooting up the middle to try and get there. And with that, what we're able to do is, again, take it more steps further, right? We want them to keep moving forward. So when they get to the chest area, we kind of like to have them stop. That would be great. So again, since this is all logic-based, you're taking every step of the way and adding to it. So with this, we want to go to and have this motion be stand, right? Now, when we have this stand motion, the thing we want them to do is we want this stand motion to kick in once they enter a certain area. Now, the certain area we have laid out over here is a polygonal plane. So this is what's essentially going to be called a trigger. So what happens is you can have characters move to an area, another animation takes place, and multiple animations can take place. So the way we want to do this, and let's kick this up over here. Let's see. All right. Let's see if I can do this way. See, trying to get to my trigger window that doesn't want to wake up. All right, jump through here. All right, we'll just jump to the trigger in this area. Okay. All right, so we're seeing this. So what we have going through is when the characters are going to the trigger, to the chest. see their movements happening. Let's wake up a bit. Okay. So once we define a trigger, essentially what's going to happen is another animation will take over. So that animation that takes over is going to be them stopping. So as I pick that stand animation, we can see that once they hit that area, they're able to stop. And now after we see in the green, you're able to cache everything out. So this is one of the big values of the Golaem layout. So you're able to cache it out, and then from there, every character, which is called an entity in here, you have the flexibility to go through and manipulate them. So if you need to do any types of translations, if you need to do any types of those movements, you have that ability to do so. And then once you're able to bake everything out, you can do what's called a vignette. Now, in those vignettes, there's ability to scale with those. So you can export those into Unreal. Unreal has a plugin where you can essentially use the Golaem layout tool to do the same types of translations. You can do any types of rotations as well. But you can also take it up another level where you can transfer groups. You could also offset different animation as you like. So let's say you copy a character. Mind you that you're copying cached out characters, so they're gonna have the same animation as the previous one. But what you're able to do is with the time warp, time speed up, let's say the character you copied from, he leads with his left foot. You could start on a different frame so that other character leads with their right foot. So that adds to the different variants that you can do as well. And then when you're done with your cache, you kick it out over here into the cache library, move it to Unreal, or you could even move it to another solution like Max to render. And with that, I'd like to pass it over to Jose, talk about 3D Max.
Thanks. Am I on? You guys hear me? No, not yet. He's turning me on. You want to give me the HDMI? Oh, I'm on. Do you guys hear me? Yeah. Awesome. I don't know how we're doing on time, Jeff. How are we doing on time? I'm just going to assume we're on time and just throw something at me to stop. I heard Jeff say 3ds Max is awesome tonight, and that made my day. Can you give me the HDMI? Oh, yep. Sorry. Okay. I don't need power. I'll be fine. So hey everyone, my name is Jose Lizardo. I'm a 3ds Max solutions engineer. I like to call myself the Max cheerleader. I've been working for Autodesk. Wait, do you guys see my screen? Wait. What's going on? PC screen only. Duplicate. Are we seeing your desktop thing? No. It's not? Yeah. Yeah, 2. Where is it? Yeah, number 2. We'll get this. All right, awesome. Let's jump in. So, hey everyone, Jose Lizardo, Max Technical Specialist, Solutions Engineer at Autodesk. Oh, thank you. I've been with Autodesk for about 20 years, been using Max for over 20. I'm Jack of all trades, master of none. I talk about Max in Canada and US to customers, events like these, conferences, SIGGRAPHs, GDCs, you name it. I got about 15, 20 minutes. It's just a lot of demos, and I'll stop when someone throws a brick at me. I don't want to get in between you and Crafty Apes, because that's the main event tonight. That being said, this is who I am. I'm the Max cheerleader for Canada and US. I love Max. I've been using Max for 20 some odd years. And I heard JF say that about Maya. I feel the same way. I got Max tattooed on my heart, and I'm always going to love Max, and I'm always going to be using Max. So let's jump right in. Without further ado, these are the topics I want to cover. A lot of procedural workflows. Max is not a procedural tool per se, but there's a lot of procedural paradigms, procedural systems, the modifier stack, a lot of the rigs we have, a lot of the shading systems, non-destructive procedural workflows, little robots, so to speak, is how I like to frame the workflows that we add to Max. And we've been adding a lot of things to Max, especially on this sort of modeling, world-building, procedural, non-destructive space. Let's jump right in and talk a little bit about, I like to call this procedural world building. It's just tools. You can use them however you want. First one up is the array modifier. We added this like a year ago, more or less. This is an instantiator, very much like Mash and Maya without the physics engines or the collision detection. So it's a way of instantiating objects across your scene using different kinds of array types like linear array and radial array and grid array and surface array and ray casting and all sorts of crazy effects that you can do with one object. I'll show you guys how to build out this particular scene here using these cobblestones, all non-destructive, all stack-based. Everything that I'm building is always in the stack. I don't push and pull vertices. I modify geometry using modifiers and stack it all up so it's all non-destructive. I can go back, make changes upstream, downstream, everything's connected, creating robots in our scene. So we got with this box, we're going to throw a taper modifier on it to give us the initial volume and shape. On top of this, I can throw a chamfer modifier to give us the beveled edges. We can smooth this out with a turbo smooth modifier. And then I like to throw on a displace, excuse me, to give us the bumps that we need on our block using a noise map. On top of this, I can throw my array modifier, and then I have access to all the settings of the array modifier itself. We can, of course, increase the clone count over X, Y, and Z. In this case here, we're just creating a ground, so X and Y. We can change the pattern type. We're going to set ourselves to alternating, define the offsetting. Where the magic really happens in this modifier is in the randomization tab. You can randomize every aspect of the clones you're making: position, scale, rotation over X, Y, and Z, connected or disconnected. Every value has a seed value that accompanies it. So if you want to create a new random pattern or distribution, just play with the seed value, increase or decrease, and it completely changes everything. Again, everything's living in a stack, everything's non-destructive. If I make changes to my initial block geometry, everything that's on top of the stack will come along for the ride. In this case here, we throw a bend modifier over everything. We increase the clone count to follow that curve. We also have the ability to remove objects that are being cloned, either with a removal percentage or a call object, and we can change that pattern using the seed value as well. Tons of stuff in here. Again, this is a very quick demo. I'll show you guys one more demo on the array modifier. Don't laugh at my water animation. This is not Nomen worthy, I understand that, but it's not the point of the demo. What we're gonna do is create a crate using just the array modifier. So we're stacking array modifiers, creating linear arrays, linear copies, rotating them over to create all 6 sides of my crate. Once I have this all set up, I'm going to add another last array modifier and have it clone along this spline that you see up in the sky, these spline segments. So it's going to create one clone of that box per segment. What's really cool is when you're set to spline array, I can use surface ray casting. So we can ray cast this down to a projected surface. Here we're going to pick our ocean, and you can have the crates follow the local normals or the orientation of the topology. So as those waves move around, and I hit play on the timeline, all the boxes come along for the ride. They're all connected, it's all procedural. I can make changes anywhere I want. I can grab a spline in the sky, move it around, and the connected box will come along and follow those normals on the ocean. These are the kinds of things that, this is the way the developers think about building tools into 3ds Max, creating little robots. Another workflow I'll show you here is with combining multiple modifiers, the array with the new Boolean modifier, which I'll show you a little bit later, to create these terrain type, unique looking individual terrain type objects. So here we have a collection of boxes. This is just one box arrayed onto itself using the array modifier, right? We've got some subdivisions in there that are going to be necessary for what we're going to do later. If I don't like this distribution, I can hit the seed value just to create a brand new random distribution. I'm going to create a reference of this just for demo purposes. This is not the actual workflow, just to illustrate what's actually happening, right? So as I change the seed on one, the other one comes along for the ride, referencing standard workflows of Max. So on top of this, now we're going to start creating our terrain. So I have this block here that's got the shader that I want with the textures that I need. I'm going to use the Spherify modifier again to give it some curvature. We're going to throw an array modifier. We're going to use a surface arraying, and we're going to pick per vertex. So it's going to create a clone of that box on each vertex of that arrayed collection of boxes. Now, right now, this is nothing useful. So what we're going to do is we're going to use the new Boolean modifier. The new Boolean modifier is, I'll talk about it in another demo, but what's really awesome is that there's different ways of meshing geometry using Booleans. So we're not using the Boolean modifier for traditional cutout effects or cutout operations. We're using it for its OpenVDB implementation. So we implemented OpenVDB into Max, and we implemented it in the Boolean modifier. So we can mesh a piece of geometry using voxelized workflows using the Boolean modifier. So we're going to voxelize this mesh. And it's basically going to remove any interpenetrating geometry. I can, of course, add more resolution if I want using the voxel size spinner. In this case here, I'm satisfied. To add more res, in my case here, I'm going to throw a subdivide modifier on this. We added some algorithms to subdivide the last release. And throw a displace modifier so I can create my erosion lines. To do so, I'm using a noise map that is tiled over Z 5 times to create those nice patterns. And what's really great now is if I go to my referenced object, right, this whole system you see on the right is a robot. It's just a system that I created. When I go to my yellow boxes and make changes to my seed, everything comes along for the ride. So I can create any number of these unique pieces of geometry just by increasing the value of a spinner. I bring in shaders, lighting, environments, and grass, and very, very quickly I can create any unlimited number of completely unique looking assets. All right, so that's one workflow. Yeah. All right, so procedural modeling workflows. Let's take a look at, we keep changing Booleans in Max, so it's almost like a tongue-in-cheek. It's like chamfering, it's getting a little old. But the new Boolean system that I just showed you is a modifier, and it changes, in my mind, the game completely with Max as far as it relates to using Booleans. Traditional Boolean workflows in Max, or probably even in Maya, are very destructive. If I have an object that has a stack, a modifier stack, and I bring it in as an operand, I lose all that information. What if that information could live on, and if I make changes to a stack on my operand, all of the Boolean system updates? That's what the Boolean modifier brings to the table. So we have a cylinder. We're going to create that telescope that we just saw as a reference image. I have a cylinder here, and I have a chamfer on top of it, creating my beveled edges. And in between this, I'm going to add the Boolean modifier. So everything I add to Boolean gets the chamfering on top of it. That's why we stack it this way. So I'm going to bring in my tube as an operand, as an addition, and you see immediately I'm getting those nice beveled edges. This was not possible before. Using the shift key, I can clone my operand across my structure, and all I'm going to do now is just create a whole bunch of different clones and push and pull using different operation types, Boolean operation types, to create my initial starting point volume, my initial geometry. And then I can start adding more details to this. Now all of these tubes, whatever they had stored on them, selection sets, modifier stacks, mesh data, whatever that is maintained. It's not squashed when it's brought in as an operand, which is a really important distinction in this workflow. So here I had a selection set of the outer faces of that tube saved as a selection set. I'm going to select those in the Boolean stack, and I'm going to extrude them using my the extrude function. By polygon, I'm going to convert that, I'm going to scale those faces in along the local normal. I'm going to take those faces, convert them to vertex selection, and I'm going to collapse those in to create my ribs that we saw in the reference image. On that operand, I can add an array modifier. Again, Boolean's picking up all this. It's doing all the entire connection of the mesh. I have this block here that I'm going to use to create the ribs that we saw in the reference image, the rubber ribs. I'm going to throw an array on it, bring it into my telescope, position it where I want, increase the clone count, and bring it in as an operand into my Boolean stack. Now, as I make changes to the array modifier on the box, the original box itself, the clone count, the Boolean's taking all that. So it's fully procedural, fully non-destructive. I can make any changes to any parts of this, and everything comes along for the ride. We also added the conform modifier to 3ds Max. This is a way of taking a piece of geometry and applying it to the topology of another geometry and having it flow on the topology properly. So we have two types of conform methods. We have the standard method, which is the volume method, which attempts to preserve the volume of the original object that you're projecting onto another object. And we have skin wrap method, which basically takes an object and skin wraps it onto another object. All of these settings and how these two objects interact with each other are fully customizable, fully editable after the fact, but it's a really great way of producing the effects that you see on screen. Armature on characters or anything that needs to lie on top of the topology of something else. Yeah. That's my colleague Scott Eade, by the way, who did that with Bifrost. So. All right, so we added also brand new texture baking workflows to 3ds Max. Anybody in the game space? It's gamifying high-res assets. So in this workflow here, we're going to look at texture baking to extract normal information from a high-res mesh, as well as retopology and some other workflows to create a low-res simplified version of a high-res sculpt. This is a mesh of a sculpt from ZBrush. It's got 35 million faces. And in Max, that just behaves really well, but of course, this is not game ready or exportable in any way. So the workflow that I employed here is I removed half the mesh because it's symmetrical using slice modifier. On top of this, I throw a Pro Optimizer, which decimates the mesh down to something that's more manageable, more digestible, more consumable. But of course, the Pro Optimizer, although it does a really good job of maintaining the overall volume and silhouette, it does give you soup of triangles. So instead, what we're going to do with that mesh now is we're going to give it to retopology, which we also saw inside of Maya a little bit earlier. So we could define a polygon budget. We compute the retopology, and you got a bunch of settings in here to define edge flow and whatever you need, right? But you get nice, clean quad-based geometry from a input of a garbled piece of geometry. We also have Flow Retopo in Max. I don't show it here, but it's the ability to offload this compute process to the cloud, just like we saw in Maya. We also have that in Max. And now what I'm going to do, of course, is bring in the other half of my mesh using a symmetry modifier, and then I can start baking and extracting. Actually, before I do that, I'm going to create LODs of this mesh. So I'm going to create any number of variations or resolution variations depending on my target platform, whether it's mobile or a PS5 or whatever it may be, right? So I just create copies of this, throw on the retopo, and decimate it further down. I'll skip this a little bit so we can accelerate. But you see we can go to something that's all the way down to 15,000 faces, but no details, right? So we want to capture all those details as normal maps. We're going to use a brand new texture baking platform inside of Max, extendable through C++, but we support V-Ray, Corona, Arnold, Redshift render elements. In this case here, we're going to be using Arnold's normal element baking. So we're going to bring that in. We're going to set ourselves to 4K. We're going to be creating a PBR material, and we're going to connect this normal map that we're going to generate into the PBR normal input. And we're going to be using cage projection workflows. So we're going to be looking at the high-res mesh, capturing all that surface detail, that high-res sculpt detail, as a normal map. So to do that, again, we use the projection workflow, and we're going to just adjust our cage. The idea here is to adjust the cage so that it doesn't overlap with the geometry in any way, or it might have artifacts. I'll skip through this just a little bit. I know we're running short on time. And then you hit bake, and it basically uses the UVs on your low-res mesh to create the normal maps. These are side by side, the high-res 35 million faces, low-res 15,000 faces with a normal map. They look identical, so you can't tell them apart. And one is exportable, not agnostic to 3ds Max. It's a PBR map, it's just a texture map. And it's just low-res geometry. All right, Flow Retopo, I talked about that a little bit earlier. We won't cover that. These are some examples of some assets that I worked on in the past that I used these workflows to produce. Procedural animation, one last little section before we call it. This is a very simple animation, right, of a barrel hanging, swinging in the wind. You want to produce this, you'll probably be tempted to throw in some bones and then rig it and skin it and keyframe it, but I got time for that. No. So instead, what we're going to do is use procedural animation controls inside of 3ds Max to produce that. So really quickly, what I'll do here is I'll select a whole bunch of vertices inside of Max, the vertices that I want to be swinging. I want to create a soft selection or a feathered selection of where the kink happens. So this is the starting point, and what we're going to do is use this and feed this selection into a bend modifier. The only thing that's going to be animated is the bend itself. So we're going to bring the bend, we're going to isolate the bend kink location, which is in the upper part where it reaches the wheel there. And once we have our bend set up, this is where we're going to create a procedural system that allows us to adjust to any timeline changes or any modifications down the pipe that might occur, because it'll just adapt to any one of those changes. So we're going to create one keyframe on the direction, just to have some frame information, some keyframe data, some animation data that we can play with inside of Max's animation controller system. So we open up the track view, and we're going to look for our angle track here, the angle of the bend. And we're going to replace the position scale rotation of it with a waveform float. This basically allows you to create this type of animation that you can then control in the waveform controller UI. That amplitude and those waves can all be defined in here and how they behave and how they interact. But rather than keyframing this and moving things around, you're basically just controlling this at a higher level from a procedural point of view. So here we're creating the waves that we want, so that effect of it flowing in the wind. But of course, the direction has, oh, sorry about that. The direction value was animated to frame 100 more or less. And of course, we want the direction to just keep animating. So what we're gonna do is select our our direction track, and we're gonna replace it with an out-of-range track, an out-of-range controller. The out-of-range controllers allow you to define how how the object will behave leading into your animation, your keyframe data, and how it exits it. You can do ping pong, cycles, loops. In this case here, I'm going to set myself to linear, so it's going to follow the exact same animation that I've keyframed in and out. So that number, that direction value will just keep increasing no matter how long my timeline is. And of course, my angle is defined by a procedural wave that I can then modify and I can add to and I can stack to, of course, if I wanted to. I know we're running short on time. I'll do this super quick. We added the ability in Max now to stack transforms and mix between them. So think of this like as a mini motion mixer. So we're stacking transforms onto this object here, and we're isolating animation information and blending between them. My first track here, I have the takeoff animation. You see lift off in the upper right. I'm going to add into my available slot here. Again, I can have any number of these different tracks that are all mixing together. I'm going to keyframe a bit of an offset, right? So I'm just offsetting that animation, layering this offsetting information onto my original takeoff animation, but isolating it so I can only control this and have it just mix really nicely. All these controllers can be turned on or off. They can be animated on or off using different control types as well. And then I'm going to grab one more controller here, one more available slot. This time I'm going to grab my rotation track only and replace its Euler XYZ with a noise controller. So now the rotation on this specific track is controlled by noise. Of course, it's a bit too much. We don't want him to look drunk. Just taking off a little bit. There we go. So you got a little bit of noise with a bit of an offset layered onto the initial takeoff animation, all blending really nicely together. I'm going to end on this. I want to make sure you guys know that Max has a great looking viewport. Oh, sorry about that. Nope. Come on, hit play. There we go. Max's viewport has seen a lot of improvements over the last several years. It's fully PBR supported, PBR shading completely from a standard PBR kit. It's got IBL support. It's got glare support. It's got depth of field support. It just looks freaking great for a look dev environment, especially on individual assets. It's just a great looking viewport. So there you go. We're going to cover this, I think, a little bit later, the roadmap stuff. So with that, I'm going to pass it on to Bo to introduce to you guys the main event of the night. Thank you.
All right. Thank you all people at Autodesk. Appreciate sharing this amazing work with us. I'd like to pass this on to Mr. Sean Willis, though. He's the senior technical artist and pipeline TD from Crafty Apes, with a bevy of credits under his belt, including Thor Ragnarok, Spider-Man No Way Home, and Stranger Things. Thank you, Sean Willis.
Yes, please. Oh, there we go. There we go. Check 1, 2. Check 1, 2. No, there's no audio for that. Yeah. All right. Hello, I'm Sean Willis. I'm a senior technical artist and pipeline TD at Crafty Apes Visual Effects. Crafty Apes is a high-end full-service visual effects studio. We service our clients all around the globe. I started there 8 years ago, back when it was in Culver City, back when it was a very tiny office. I administer the pipeline. I basically define standard operating procedure at the company. And I know Maya, Nuke, and I'm a generalist. So without further ado, we're going to be showcasing modern practices used in production. We're going to be crafting high-quality feature-level effects. So we do features, television, lots of stuff. So let's go over to the agenda. I also know that Wacom is sponsoring this event, so I have like 5 Wacom tablets at home. I love them, and I'm using the Express Key remote to advance my slides. So let's. So the first topic is going to be artist-centered workflows and pipeline technologies tailored to generalists. So generalists are, at Crafty's heart, the core of how we do work. Classic cinematic visual effects techniques is up number 2. And then controlling crowds intuitively. We have a very robust crowd system. We use Golaem as well. And procedurally amplified assets. So procedural, taking existing assets that weren't originally created procedurally and making them procedurally powered and parameterizing them so that they can be customized and tweaked. And then number 5 is an exclusive showcase of the Relic asset library and how it uses compound assets. So the generalist approach is, at its heart, multidisciplinary. It's architecture designed for artists to express greater creative freedom and provides autonomy, first and foremost. It's necessary to create the best looking shots. It enables rapid iteration, self-handoff, tighter review feedback loops, and substantially higher quality results in production. This is a known scalability and redundancy trade-off. I know a lot of places have this fixed departments that do things, and our philosophy is a lot more loose. It's a whole lot more flexible, and you allow people greater control because one artist can do a very substantial amount of the work of the creative work of the shot. And if there's like a generalist and a compositor, there's only 2 guys, and those 2 guys can be really tight. And in some cases, you can have one person who also knows Nuke. We have 3 or 5 or so people that are really talented, and they can do pretty much an entire shot by themselves. So yeah, we do not operate like an assembly line. What feeds into that generalist approach is things like, I did this shot years and years ago, and I match moved it myself. And as soon as I saw the Wonder Dynamics presentations, I was like, oh my goodness, this is going to be a very large change in how we approach our work, because this effect was using a Bifrost graph to make the person disappear. If you've seen the show Picard, this is Star Trek Picard up here. And the majority of the time it took me was actually just match moving everything. And this is actually a worst case scenario of what might happen if you're trying to have something that's flipping, the frame rate is kind of choppy, and it's a high intensity action sequence that has a lot of rotations. So, and it's a fast moving camera, if you can see on the top left, right? And Wonder Dynamics is able to process this with all of these considered and give a starting point that is better than me having to go in there and match move it there. Which of course you could set it to the match moving department, but if you're in the wanting to save time and reduce the amount of overall work in it, this is another one of those shots that was entirely done by one artist. So this is classic effects for Trek. All of these phaser disintegration shots were done with a single Bifrost graph, and they were replicated across all of these shots. It was a seamless experience to publish them. We had to basically, for 2 of these shots, one is on the bottom left corner and on the top right corner. Those 2 interact with things, and we originally didn't offer it. All of the shots where they were getting blown away didn't actually collide with anything. So it was a trivial thing to just add a collider in Bifrost, and then every single one got a new update. And yeah, they were pretty much just drop in to collide with the chair and collide with the ground. So another thing about how we use Bifrost is, I know Emergen's a very common tool that people use, and because of this, oftentimes comp will start with an emergent sim, and CG will do a takeover of that emergent sim. Because emergent allows you to do things really rapidly, but Bifrost gives you more physical accuracy, better dissipation, and in a lot of cases, you can scale up much larger because you don't need really, really crazy GPUs to simulate all of this stuff. So I was actually at SIGGRAPH this last year, and I was talking to the principal scientist, and I was talking about my doing this, and they were very interested in seeing that. So if you're watching, Rook, this is for you. But yes, this isn't a good example of how large these things can get. But oftentimes, like if you run into, like you're running on a 4 to 8 gigabyte card, running on Bifrost, you can still get that same exact thing. And yeah, if you can't tell, it's frame 7 that it does the takeover. So it's very plausible and it continues on. So it's a very good tip and strategy. So we're going to go into crowds. We have 2 distinct crowd approaches, as I mentioned. We have Bifrost and Golaem. I think it's Golaem. The single way to decide between one or the other is that we have, if people are colliding with one another, if they're interacting with one another, they're going to be a Golaem crowd. And if it's a stadium, or if it's a auditorium, or if it's a concert, then oftentimes we're going to use Bifrost. And so you can see up here that this is on the top, it is Unstoppable, a recent feature film that came out. And on the bottom, it's a Rustin. Bottom is Golaem, top is Bifrost. Now, one of the great things about the flexibility of doing it in Bifrost is that we allow the generalists to choose which application they want to make changes in. So inside of Maya and inside of Nuke, you have the exact same interface. So this is a Bifrost graph that is being controlled inside Nuke, and it's being run inside Nuke. And we are modularly building this crowd of sprites. And on the left-hand side is a stadium where we're placing seats. And the design of this is procedural so that it's a very simple stadium, but if you take something, say, from, a venue that has a layout that you see when you buy seats, it's very easy to just draw up a very quick thing in a couple minutes, and then you have a stadium inside of this. Very quick ramp-up time, and it's very easy. All you need to do is provide a bunch of extras. Speaking of providing a bunch of extras, a very fun way of doing this in Bifrost is that you're not limited to just 2D cards. We can do 2.5D elements, or we can do 3D elements, voxels. So there's a lot of great new capturing technology for creating volumetric captures of people, and crowds are going to be enhanced by this new capture technology to place people in dynamic camera movement environments, and it's going to extend the ability for us to have dynamic camera moves. As you can see inside of Nuke, there's a camera right there, and it's moving along. And there's a mask in there, so we're actually cutting out everything that's behind the camera procedurally. This is all driven by the Bifrost graph inside of Nuke. So Nuke has its own particle system, which is fine and dandy, but we want more power, we want more control, and we want more paradigm unity between the parameters, because both of them will be binding to the same skill set. Crowds are crowds in both applications, and we meet them where they need to be, and we provide them with the context and the tools in those contexts for everything that they need to do. So with procedurally amplified assets, so this is going into something else. This concept of proceduralism is extremely powerful, and what this is doing on the left-hand side is we are taking a hand that is just geometry, and you guys saw earlier that Bifrost had some pretty excellent rigging functionality, so this is tying into that rigging functionality, not directly, but it's applying simulation to it. So it's extracting the geometry as curves, as a skeleton of curves. No user intervention, no parameter tweaking. It is purely taking the distance to the center and exacting that as a curve. So it's entirely mathematical, it's entirely property-based, so it's deterministic. So on the right-hand side, I don't know if I can show the video, I was gonna put something really cool in here, but I actually had to go outside and shoot something because I couldn't get, it was NDA that we were actually gonna show this on. But you can do this with trees. You can rig up an armature for a really complicated tree, maybe from Spree Tree or whatever you were in, and start simulating it in the wind. And that's a really powerful tool to have when you're at a place like Crafty Apes. Crafty Apes does a lot of takeovers. There we go. So we get a lot of trees from people that we didn't start with. We're taking over a shot that maybe they couldn't finish, or maybe the client wasn't happy with, and so we get a lot of slop as scenes inside of here. So we have these like 2 million polygons for a tree, and this tree's leaves are not instanced. So we use Maya's, what I call their retopology supremacy. I haven't used ZBrush's retopology in years because Maya's one has gotten so good, and it matches the curvature better. And so we have a procedural graph that allows us to basically generate proxies, and we have context menus to swap between those proxies pretty much seamlessly. Along with that, we have a bunch of pipeline around redundant component deduplication. So this is a graph that uses principal component analysis, and what that means is that it's going to analyze the entire mesh. It's going to pick apart the parts that are redundant or that are encoded twice, but you just don't know it, right? Whatever rotations they have, even through animation, you can extract, there's only 6 leaves on this. Why on earth are they not instanced? They're not unique, so we take that, we take the actual mesh of it, so if it's deforming, it's actually the internal structure of that. And on this, the right-hand side is a spaceship where there's a bolt, and that bolt is instanced around. We can basically deduplicate that so that when it goes into our asset library, the asset library only writes it once, and we have space savings. And that's the Bifrost graph down there. All right, so next is the relic library and compound assets. So us as generalists, we are constantly trying to reuse things. We're trying to have elements that are shot, elements side by side with elements that are simulated, and we want a seamless, unique experience when we work with those. So Relic Asset Library is a unified interface for tools, software, shading, lighting, references. We put all of our stuff inside of here, and you can basically browse through it. Not a lot of people showcase their internal libraries. I actually don't see them very often, but this one's massively scalable, and it's artist-oriented. So it's entirely time to first element. So as you can see, there's a bunch of fireballs that you see. These are all grouped together. Why they're grouped together is in most libraries, you'll see lists and lists of a single element, and then you get all the different variations of that element. What Relic does is that it groups all the ones that are similar together so that if you know, like, I'm not needing a fireball, you skip over 16, you don't have to, your eyes didn't have to go like, oh, that's not a fireball, that's a fireball, that's a fireball. It encodes it as a group and allows you to, you know, quickly find things. So yeah, and a very important thing is a strict ontology and computer graphics semantic classification system. That's something that seems really boring and simple, but when everything's consistent and you can find things consistently and you can be like reason about like, oh, I know exactly where this thing is, it's very magical to be able to know exactly how something's gonna be called or what it's gonna look like. So we always have like people that are librarians per se, handling these things. Fun fact, my wife was actually one of the people that was ingesting all of these action visual effects elements, and she loves watching documentaries. She likes true crime, and she starts noticing action visual effects being used in those documentaries. She's like, I see that element, and yeah, so it's a fun little walkthrough of seeing just how popular these elements are and how useful they are and how widespread that they are. So Crafty Apes uses these quite a lot. Along with that, it has Relic integration plugins with Maya, Nuke, and Flow, formerly known as ShotGrid. What this allows you to do is basically exchange assets in between the two. This is a drag and drop interface. This is a pole lantern. The lantern is a different asset so that you can use it independently. And the pole itself is also completely unique. So if you were wanting to say, I have a character walking with a lantern, you could track that completely independently. You're not locked into just having, oh, this is the pole and the lantern. And similar to, if I can go back to Yeah, this slide. The bolt is a component that would live by itself. Now, every spaceship, anything that reuses that component, it only encodes it once. So when you have a registry, you can encode the, using Bifrost, you can encode the signature of the mesh using whatever, there's a variety of algorithms that you can use to basically uniquely identify a mesh. And you can register that inside of the library. And then every single time you export anything into it, you never have to do it a second time, and it will just say, hey, we already have this, you don't need to do it, right? The end. Thank you for your time. And I'm going to hand it back off to Bo.
Yes, thank you so much, Sean. Thank you for sharing this amazing work with us, and thank you to Autodesk. We are going to sign off on our live stream right now. So thank you all to everybody joining us on our stream. And we're going to keep going here, so no one needs to leave yet. But one last time, thank you all for joining us. And we'll see you back here at the next Nomad event. Thanks so much.
Wow.